Hello student, today I am going to teach you about the data reduction techniques in data mining. Data reduction technique can be applied to obtain the reduced presentation of the data set that is much smaller in volume yet closely maintain the integrity of the original data. Here in data reduction, we reduce the size of the data, volume, and also the number of attributes. Is still we do not lose any significant amount of information, and we also maintain the integrity of original data. It means the overall information that we can analyze or retrieve through the data is remain very same or remain very same. So for performing the data reduction, there are three techniques that are used. First one, dimensionality reduction. Second one, numerosity reduction. And third one is data compression. In dimensionality reduction, basically what we do, we reduce the number of attributes, or we select certain attributes which are considered as the representative attributes or prime attributes. Out of the given n number of attributes, we select few number of the attributes that are considered as representative or prime attributes. In numerosity, we reduce the size of the data volume. In it, different techniques are used like regression and something like that. I shall discuss this later. And in data compression, we represent our data in concised form, so that the actual we do not. And there are two techniques, and the lossless and lossy. So first, we start with the dimensionality reduction. In dimensionality reduction is the process of reducing the number of random variable or the attribute under consideration. The attribute subset selection is a method of dimensionality reduction in which irrelevant or weakly relevant or redundant attributes are detected and removed. As it is written here, in it we find out what are the prime attributes that are playing the major that are contributing the major informations. So instead of taking all of the attributes, we just filter out the major attributes among the given attributes, and some of the attribute which can be derived from these attributes or those do not affect very much overall information of the data are reduced from the given set. In dimension reduction, there are two methods. First one is the stepwise forward selection, and other word is the backward elimination technique. In stepwise forward selection, we start with a attribute that we considered as most important or the prime representative of the among the given set of attributes. And if we find out that the result obtained through this single most important attribute and the overall collection of the attribute, is it same or not? If it is not same, then we add on the next most important attribute along with the first one, and then again this process of analyzing that is the given result or analyzed information is same as the combined set of the attribute or not. And in next step we add on the third representative attribute, and this process continues until unless the given set produces the same same amount of information as the complete set, or it produces a very insignificant difference. This is called the forward selection technique. In it, we start with just here in the set, there are 6 attributes: A1, A2, A3, A4, A5, A6. We start with the most prominent attribute A1, and then we check out the results. If it's not satisfactory, then add on the second A1 with A4, and again check or validate that is it the is the equivalent set or not. Then we again at last when we design a set with combining element A1, A4, A6, we find out that this is equivalent to the attribute set of 6 element. And so in this way, stepwise forward, we find out the optimal selection, yeah, optimal selections for the attribute set, yeah, reduced set of the attribute. In the second technique, we do just reverse of this. It is the backward selection technique. Instead of finding out the prime most important attribute, we start by removing the least significant attribute, yeah, least important attribute. For the same set A1 to A6, we eliminate the A2 attribute that we considered is the least important, or then after the final set of 5 element A1, A3, A4, A5, A6, we find out, analyze the results. If it's not, if uh, if it's satisfied, then if it is equivalent to the last set, then we again move to the next step by removing the second least important attribute, that was A3 here. And after removing that, the given set is results is compared with the initial set of the sixth attribute. If the results are same, then we move to the another step, and the final set A1, A4, A6, which is the set which is shows the equivalent result to the set of the sixth attribute. After we after removing another least important attribute, we find out that the results are not same as the initial sets, so we stop here, and the final reduced attribute set after the backward elimination we get is the same as A1, A4, A6 that we got in the previous step, that was the forward selection method, A1, A4, A6. So either of these two techniques can be used, but to make the fast approach, we can perform these two approaches simultaneously by performing the bidirectional selection and elimination. In it, we can, in a single step, what we do, we remove we add the most important attributes, and along with this, we also eliminate the least important. In each step, one most prime attribute is added, and the least important attribute is removed. So that's all about the dimensionality reduction. Then the next step method that we were discussing was the numerosity reduction. The numerosity reduction technique replaces the original data volume by alternatively small form of data representations, maybe the parametric or non-parametric. In this technique, we reduce the size of the original data, and for reducing the size of the data and not losing the information, there are two methods. One is the parametric method, another one is the non-parametric method. In parametric method, there are two techniques: regression and non-linear log linear model. In these techniques, a model is used to estimate the data so that only the data parameter needed to be restored and not the actual data. It assumes that the data fits some model estimates model parameter. In it, we analyze our data and find out the relation between them. That may be some regressive relations, and by these relations, if some attribute can be projected with the help of the another one, then we add on just single attribute, and we do not, and by using the formula we can calculate the second variable value. So in this, we consider that data is following certain model, as here defined. First out, the model is defined, and as per given model, we reduce our data volumes. The in log linear model, the number of similar kind of variable after taking the log project nearly to the same value or very slightly different value, so that we can project a large side volume on a smaller scale. The next, non-parametric method. These do not assume the data and use for storing reduced representation of the data, which include histogram, clustering, sampling, and data cube aggregation. In these techniques, we use the compressed data representative method like histogram, clustering, and data cubes, which can store multi-dimensional data in very small amount of compact space. And in this way, we can reduce the volume of the data significantly. By using the multi-dimensional data in data cube, we can reduce the size significantly rather than storing them in a snowflake or other star schema like structure. Similarly, for histogram, the lot of information can be simply represented in a histogram instead of defining and designing the tables. And clustering, we can cluster out the simple all data's relative subspaces into a single cluster space, and they can be represented by a single variable, and this way the non-parametric can reduce the data volume significantly. The next one is data compression. The data compression, as we all know, it is applied to obtain the compressed representation of the original data. And there are two methods, the lossy and the lossless. In lossy method, in the compressed representation, we lose a little bit amount of information, but in the data can represent the original one very efficiently. And in the lossless, we compress the data, and it do not lose any bit of information. And second one causes the lossless data reduction technique. So these are the technique that are used for data reductions. Thank you.